Good afternoon. My name is Eric Mucklow with headquarters of the U.S. Army Corps of Engineers in Washington, D.C., and this is the first of our 2015 Sustainability and Energy webinar series. Today we will be talking about cross-laminated timber, aka CLT. CLT is an engineered wood building system designed to complement light and heavy timber framing designs. This presentation will introduce CLT with a series of project examples that demonstrate its use and benefits in a wide range of applications. Our presenter today, Scott Breneman, is a licensed structural engineer and professional engineer in the state of California and senior technical director of the Architectural and Engineering Solutions team of WoodWorks. WoodWorks is an initiative of the Wood Products Council, which is a cooperative venture of major North American wood associations as well as government agency and other partners. In the web links box down on the right-hand side of your screen, we have provided links to both the woodworks.org site as well as another site that provides useful design and reference materials. Again, today, as with most of our webinars, AIA credits are available in groups of 5. 5 sessions with quizzes will be issued, and if those are returned with the correct answers, you can get your learning units. To do that, go to the website shown on the screen here for the quizzes. They usually will be uploaded within a week of the presentation, and send your completed quizzes to the S&E webinar mailbox. So with that, I will turn it over to Dr. Breneman.
Thank you, Eric, and good morning and good afternoon to all of you, depending upon where you are. I'm sitting in Oakland and looking out from my hotel room at the Oakland Hills, and it's a nice day out here. So for those of you who don't have the opportunity to enjoy the weather today, I feel like I'm privileged to be here. I'm traveling for work, but was able to take the time to present this topic to you. And let me keep moving here. Okay. Kind of have the course description. Eric kind of gave a little introduction to what this is about, so I won't read that to you. And we have our required AIA learning objectives as required for the AIA format of credits. But I'll get on to the outline so you can kind of give an idea of what we're going to go through today. We're going to talk about cross-laminated timber and kind of where it's coming from and how it's kind of an element of this family of products called mass timber, and a little bit of the history of where we got to, how we got to where we are today, and the development of this product over time. Some of the reasons why developers and owners are looking at it. So what's the appeal of this component in their building systems? And then go into very briefly how to, using CLT, different project examples, some of the recent developments on the building codes and product standard size, and then finish off with some availability and other information. And I believe we'll have time at the end for some questions and answer. Eric, is that how we're going to format this? Well, we'll leave some time at the end for some questions.
That's true. We'll have a Q&A at the end.
Okay. And so I'll try to pace things so we have some time for that at the end. So if you, as you go along, jot down some questions you have for me, that'd be great. So cross-laminated timber is really one wood product in a whole new class of wood products. Sometimes you see this mass timber concept word used, which is really, kind of taking the heavy timber ideas that have been around for decades or over a century actually, and say, well, it's what's more than just a heavy timber. I mean, heavy timber historically was, large solid sawn members and kind of large industrial kind of buildings. But as kind of technology has evolved, we have new products that are similar to that solid sawn heavy timber, but really engineered, manufactured products. Glulam being one of the oldest and most established of those products, but it's not the only one. So here's several pictures of projects from around the country and around the world. There's a Richmond skating oval in the top left corner, which was built for the Winter Olympics. On the top right, you're kind of looking up at this curved glulam roof system in the Oakland Oakland Christ of Light Cathedral, which is a really nice project. In the middle is an interesting one. It's the Metropole, what's called the Metropole Parasol in Seville, Spain. and that is actually using a panelized product, so large flat wood panels, in this case made from LVL. These are all kind of just examples of these new, kind of large timber products that are really refined, and CLT is kind of one of these. The bottom right-hand corner is a picture of a building that we'll see some interior shots on that was built mostly of CLT. So CLT, cross-laminated timber, while it's fairly new to the U.S. markets, when you get down to it, it's not hard to understand. If you're familiar with glulam, you take glulam, you take a bunch of boards, are called laminations, and you glue them up in one direction, all parallel, to create a large beam or column. Well, cross-laminated timber is a similar idea. However, instead of laying up all the boards in one direction, you alternate directions or cross-laminate them in kind of a layered fashion, like you see on the screen. And in a way, it's similar to plywood. Plywood, you take veneers and layer them up in alternating directions to create kind of layers which have a higher strength in opposing directions to kind of create a system that has strength in two directions. The same idea applies to cross-laminated timber. It's just now, instead of thin veneers, we're laying up with dimensional lumber pieces. So this is a much larger panel than a wood structural panel like a plywood would be. So cross-laminated timber kind of has this basic composition of laying up different boards in the opposite directions. When it's manufactured, you use kind of very well controlled environment. You're using lumber that's all been dried to a 12% moisture content. So it's not green lumber that's going to shrink very much after it's put in use. And you create these large slabs at the manufacturing facility, and then you actually can do a lot of finishing work or manufacturing of that for specific buildings. So panels can be planed and cut to size. You can have windows cut in them. So basically you can kind of create these panelized systems of cross-laminated timber that are ready for assembly on site with very little on-site work. And that's really one of the advantages of this approach, or one of the possible advantages, is to have a lot of on-site precise fabrication done that really speeds the on-site construction. A little bit of the history of CLT. It's a technology that's been around for over 20 years, starting with initial research in Europe and Austria and Germany in the 1900s. So over those past 20 years, it's really developed into a pretty mature product in Europe, just steadily growing there. And in the U.S., interest really began in the late 2000s, where we have really developed the manufacturing facilities in North America, as well as kind of developed the U.S.-based product standards and codes, so that now we're really getting to the point where we have kind of a mature standardization process and a mature capabilities of the CLT manufactured in North America. And we'll go through some of those particulars in a little bit. But it's fairly new to the U.S. It's becoming mature, but it's not a new technology. It was invented, kind of by research over 20 years ago in Europe. So what's the appeal of CLT? It comes from a couple of different factors. One, this massive timber, these large wooden panels are very strong, relative to other, small dimensional lumber pieces. These are strong members. One of the applications for CLT that's not in building construction is using them as temporary rig mats underneath cranes, or if you have a environmentally sensitive area that you need temporary road access. One of the applications is building a temporary road out of CLT for the trucks to go in over this and just be able to pick it up when you're done and have a minimal permanent impact on a site. So it just kind of gives you the idea of the strength that these have. Meanwhile, they're fairly easily modified and cut. You can screw them together, and you can have easy manufacturing at a facility or on-site modification of them as well, which really lends itself to lots of flexibility in what you can do with them. the pictures here are all from different projects, giving some examples of very tall walls kind of on the left and the bottom left. You know, the center kind of mid picture is a project where it's using CLT for the floors and CLT for walls. The top right is this floating staircase at this at a university project in British Columbia, and you can't quite see it from that picture, but there's nothing supporting that staircase. It's really cantilevering off the floor that it's connecting to. There's no poles or metal cables between those landings. Just kind of an example of the flexibility and strength you can work with this. And one of the properties that some designs like and take advantage of is their ability to span in two different directions. So it's not just a one-directional span. You can actually span in two directions, as is the case at this cantilevered roof corner, where it's cantilevering off the post in two directions, so without any additional structural framing supporting that. So it kind of gives an idea of the different structural configurations that it can be used in. It's a lightweight product. It's not going to be picked up and moved around by hand very often, but it can be moved around with much lighter cranes than a precast concrete would require. This is useful during construction, but it's also useful during design and the implications on the foundation. A lighter building means maybe less work needed in the foundation zone, whether it's on piles or on a concrete footing. The lighter weight building may be able to have less foundation work required, so it can save some costs outside of the direct impact of the structural framing. We kind of mentioned the prefabrication attributes. It's definitely an advantage where a lot of the work can be done off-site and be assembled on-site for speed of construction or limited access. There's many reasons why you want to consider this kind of panelized construction, whether it's CLT or other things, but CLT lends itself well to kind of precise off-site fabrication for quick on-site assembly. Which obviously can lead to a reduced construction time. We have some projects later on we'll show where kind of really took advantage of that reduced construction time. As with most systems, if properly designed and detailed, it can develop a very energy efficient envelope. It's a uniform panel product, so that you don't have a lot of variations where you have air leakages at certain locations or thermal gaps, thermal bridges at certain locations. It's just a mass panel product. It's not going to be a finished product by itself. If you have insulation required on the outside of a building, you're going to have some exterior enclosure, but it can be part of a well-designed system. You kind of see in the bottom left corner where they're taping up the joints, between two panels. So it's going to require details like that if you're using the CLT as a air barrier, for example. But it can be part of an energy efficient system, which is something that's important to all our new designs these days. So we'll kind of look around some of the projects that are around the world, and then we'll kind of move to a little closer locations to home. To start with that one picture I showed you early on. This is a Stadhouse residential project at Murray Grove, London. It was kind of one of the first tall modern wood buildings that kind of started off this revolution we're going through right now around the world of considering using wood products in taller buildings than we have very much recently around the world. And so this is a 9-story tall building. It's 8 stories of CLT over a 1-story concrete story level, almost 100 feet tall. Completed nearly 5 years ago now. And the upper 8 stories use CLT as the only real structural component. So you see in the top left a picture of one of the units before it was closed in, and then actually in this particular project, all of the CLT was, enclosed behind finished surfaces like, the gypcrete or something, gypboard, wallboard, or wood flooring. So really, if you look at that picture in the top left of all the wood, that all ended up being covered up and none of it was exposed in the end. But underneath, all the walls and the floors is the CLT as the structural framing system. Another benefit that this particular project really took advantage of is the sustainability attributes. In London, they're required to have a carbon offset program for any new construction. This particular project was able to use the reduced carbon emissions of the construction of the building as well as the carbon embodied within the CLT, so that net sequestration and the reduced emissions from a lower energy product that had lower energy during manufacture, and they used those two things as their carbon offset for the requirements of the building department. In a way, what the carbon sequestered and reduced through the use of CLT on this project was equivalent of having 20 years of a net zero energy project. So they could have put the photovoltaics on this system to have a net zero energy building for 20 years. But if you look at the size of the building and the kind of the roof size relative to the floor space, they probably didn't have room for the photovoltaics for that route. But this the carbon sequestration of the CLT was used for their carbon offset, which was one of the benefits of this approach, if that's something important to the clients on the project. Another similar project that was completed a couple years ago was in the Forte building in Melbourne, Australia. It's a 10-story building. This is a 9 stories of CLT over 1 story of concrete. Similar story. In this case, one of the major motivators was the lightweight nature of the CLT. This is in the Victoria Harbour region, kind of the old infill soils, kind of poor geotechnical conditions, and the lightweight nature of this system versus like a concrete system, which was another one considered, required a lot less foundation work, and Lend-Lease, who's the developer of this project, is really starting many other projects in progress in Australia, following what they learned on this project. So this was successful to them, and they're taking their lessons learned and applying it to many other projects under development in Australia now. Just another example is a 9-story building, or there are actually 4 9 stories in buildings in Italy. Just another example of projects that have been completed using cross-laminated timber as the structural system. This one's a little unique in that all 9 stories are CLT. They don't have the concrete kind of podium or pedestal level. Another, tall wood project under construction, and I'm going to tell you now, like, we're not going to only talk about tall wood projects, but I got several of the interesting ones here up front. This one's under construction in Norway. It's going to be a 14-story tall building. It has a slightly different structural system. You can kind of see a almost exoskeleton there of a timber truss on the outside. It's kind of behind a curtain wall system, so it's protected from the elements. And the interior cores, like the elevator and stair cores, are all cross-laminated timber. So it's kind of a mixture. It's not all CLT, but it's a heavy timber, mass timber building that's under construction that will be 14 stories tall. And if you Google it now, I think they have a webcam up, and they're out of the ground. I don't know if they've started installing the timber elements yet, but they may be about that phase now. Something that's not a tall building is this school project in Norfolk, England, which was completed in 2010, just a 3-story school building that is an example of something else. It's just not a tall residential building, but other applications. Moving close to home, we're going to cover a couple U.S.-based projects, or North American and U.S. projects. So this project here that you see on screen now is the Elkhorn Lodge and Elkford Lodge in Elkford, British Columbia. It's kind of a community center built for the city. It's a 2-story building. It has a SIP panel roof and all CLT walls. Some of the walls are up to 24 foot tall, and so they're just kind of using the strength capabilities of CLT to handle those tall wall locations. It's a heavy snow load location, so there's pretty high loads on the roof for the structure. Kind of use a combination of the structural insulated panel roof, the heavy timber trusses, and the CLT walls. Another North American but Canadian application is this airport completed in Alberta, Canada, where they're using the CLT as the roof deck system, between supporting roof girders and purlins. You kind of see that in the top right corner of the underside of the CLT, supported by the beams during construction. So a large roof application, but just a flat roof. Again, I think there's a pretty large snow load at this location as well. A multifamily project completed in Quebec, I think completed last year, is this 4-story multifamily apartment project in Quebec. So it's a different application here. Moving into the U.S., this is a small little project that's completed several years ago now, but it was one of the first all CLT projects in the United States. It was in Whitefish, Montana, kind of in their downtown region. And you might think of that, sounds like kind of a small place, but they had a really small window for construction between the ski seasons and several of the kind of festivities they were having in the town. So they really needed to close down the road to get access to this small site that they were putting up this building. And so CLT was a really good fit for that, because they were able to shut down and have crane access from the street for only 5 days to put up all of this building. I think I was talking to the developer, the engineer on it, and said originally they got the whole 7 days from the city, but then something came up and they said, well, we're going to close down the street, we're going to work on something else. So you only get 4 days. So they were actually able to build this structurally in 4 days, just kind of placing the panels from the street. Another U.S. project is this Promega Feynman Center in Madison, Wisconsin. This is a meeting facility for a private company, and you can see some of the interior shots. This is it uses a CLT roof panels supported by glulam beams and glulam columns. There's like kind of a sinuous S-shaped floor plan on that. We'll kind of see, and that's kind of reflected in some of these angles you see in these framing shots here. This is a picture of installation of some of those roof panels. You kind of see, I don't know what the length of that panel is, but it's about 40 feet span, with multiple spans over the different roof beams. So you can see how if you have everything set up, you could put this roof on fairly quickly. Just crane that into place and screw it down onto the supporting beams. And then kind of an interior shot looking down the facility from the inside, and kind of see some of how that came together. And kind of a hybrid construction of different wood products, and you can see the kind of cable braces there for lateral stability. Another recently completed project is a Franklin Elementary School in Franklin, West Virginia. Well, I shouldn't say it's completed yet. I think it's that the CLT is completed. They might still be under construction for the project. But here just kind of a rapid construction of a 2-story school with CLT used for most of the structural framing. But there's applications where entire buildings aren't being built. This is a shot of a project in Sacramento that was under construction about a year ago, where they just used the CLT as a floor in the mezzanine. These are kind of like a high-end condos or high-end apartments, where you have like a high space and then kind of like a lofted bedroom open to the rest of the loft. Well, the floor of the loft is CLT, whereas the rest of the structure is traditional light frame. So it doesn't have to be the whole building doesn't have to be CLT. You could just do a roof, or in this case, a mezzanine floor, as is appropriate for the project at hand. So there's kind of some of the projects that have been completed and are underway around the world and in the country. Going to move on to kind of where we are in terms of product standardization. And excuse me for a minute. Sorry, had to take a drink and cough there for you. This is as an innovative product, there's always going to be people who are going to be on the cutting edge and willing to take some risks. But for most of us to do this kind of work in our projects, we kind of have to see kind of really product standardization and adoption by the building codes, and that's where CLT is now really getting that established. Starting with our International Building Code, which is our model building code for much of the country, and I think even the UFC references the IBC as a model building code. In the now published and finalized IBC 2015, there's a definition for CLT there, and then it references various documents from the IBC, such as the NDS, which is our National Design Standard specification for wood construction. This is our our standard for engineering of wood products in general. And also it references a product standard, which is crucial to define the product. What is the product and what does it look like and how is it tested and manufactured? There's a product standard for that reference from the IBC, and then there are reports on specific manufacturers' products conforming to that product standard. Looking at that in a little more detail, this is a snapshot from the IBC 2015 where it's defining cross-laminated timber and what it is, and then referring to this ANSI APA PRG 320 document as the standard by which cross-laminated timber will be recognized in the IBC. This is similar to, if you're using wood structural panels and OSB or plywood sheathing, there's the Department of Commerce PS1 and PS2 documents are referenced from the IBC. There's an ANSI APA document covering plywood and OSB reference from the IBC. This is that similar approach where the code, the building code, or in this case the model building code, references a product standard for recognition of products built to that standard. The ANSI APA PRG really covers basic stress classes or strengths available in CLT. It addresses manufacturing processes. It addresses testing to comply with the standard to ensure that the product being manufactured meets the required strengths, as well as marking of the product to make sure you're getting what you're asking for. So those are kind of the topics covered in the ANSI APA PRG 320. And then there are manufacturers who comply with that product report or that product standard and then have their compliance certified by the APA. Just like we would see with wood structural panels or plywood and OSB, you can have APA labeled wood structural panels. Same idea can apply to cross-laminated timber. These product reports are really where you go to for your structural strength values. When you go to say, well, what's my allowable span, or what's my allowable moment in the CLT? What's the stiffness of the CLT? Really those basic underlying strength properties that you design with are coming from these product reports, so that the product standard kind of gives a way to have those come to designers in a uniform way. And then the product standard also is referenced from the NDS as to you go to these product reports to find the underlying allowable stress values, for example, to do your design via the NDS engineering methods. So again, that 2015 IBC references a new version of the NDS, the NDS 2015, which last I checked a week ago, you can download a free version of the NDS 2015 from the American Wood Council's website. So if that's something that you want to become familiar with, you might want to go to the American Wood Council website and download the NDS 2015. The current version available for download for free doesn't have the commentary and supplements in it yet. It's just the actual specification. But they have that available for free for download, at least recently have. So it should still be there. To get CLT into the IBC model building code, there was some testing that was required. Well, for that reason and other reasons, but the CLT has been tested under fire conditions and the standard fire tests as a floor system, as a wall system. In this example, as a wall system with Type X gypsum wallboard on each side. This particular test was a 7-inch thick panel of CLT with a 5/8-inch Type X wallboard on each side, and it achieved an over a 3-hour rating based upon the ASTM E113 testing procedure. A good resource to really dig into cross-laminated timber and the various aspects of the design is how does it fit? I mean, how do you manufacture it? How do you design with it? What kind of what do enclosures look like? Is the CLT Handbook. There's a U.S. CLT Handbook that you can download for free. I think the links available for the webinar included a link to the masstimber.com. If you go to there, you can find your way to a free download of the US CLT Handbook, which is, a several hundred-page document. I think you can order, a print copy as well, but you can download the PDF for free. So looking a little more carefully into the actual kind of behavioral properties of the CLT, we kind of mentioned, it's made up of alternating layers of lumber. You have kind of a strength axis like in plywood, where the outer laminations are running one direction, and it's kind of a stronger axis or the major axis of the panel, and then the cross laminated direction is kind of in the minor axis. There's structural strength in both directions, but one direction is going to be stronger than the other, just based upon that layup. And similar to plywood, you have usually an odd number of layers to kind of have that symmetric composition. The individual boards are in North America typically 2x material that's been planed down for a smooth surface and put into the CLT. The actual product standard allows other thicknesses than just a planed 2x. So there's some flexibility for manufacturing or even custom layups down the road. That can be comprised of machine-rated or visually graded lumber, and there's different requirements on the dimensional sizes of the individual boards in the PRG 320. The layers or orthogonal directions, you have usually a symmetric layup with a odd number of layups, but the actual product standard allows unbalanced or asymmetric layups. The actual standard also allows individual layers to be made of structural composite lumber or something stronger like that as well. So as the product becomes more prevalent, it has more use around the country, we'll probably see more and more creative layers available from the manufacturers. And then you have your panels, or sometimes called billets. And really the size of them are limited by the manufacturing capabilities and often the shipping capabilities. So the manufacturers can all make 8-foot or wider panels, 40-foot or longer panels, and then it's really a question of the maximum size of the manufacturer's presses, and then the maximum size that you can ship from the manufacturing to site. So it's really large panels available. Here you see several example layups that are possible. The most common is kind of like a 3-ply 3-layer, 5-ply 5-layer, 7-ply 7-layer, 9-ply 9-layer. But there's other possibilities that the manufacturers can create, or or for a very specialized application, you could probably work with a manufacturer to create a custom configuration to meet the needs of a particular application that designers might have. On the topic of product availability, there are, you saw earlier, kind of two shots of different product reports available. There are 2 current North American producers of structural CLT for building applications. There's some additional manufacturers for kind of like the crane rig and the temporary road applications, which is kind of a different application, so it's not the exact same CLT. We have 2 current producers. Both of them are in Canada. However, there are several more companies that are in development of manufacturing facilities in the U.S. And some of those are very close to going into production. They have had test test manufacturing, and a couple of companies are on the verge of starting up full-scale manufacturing in the U.S. It's not quite a commodity-based product where you just say, I'm going to have CLT, 7-inch thick CLT, and go bid it to the cheapest supplier. It really is, at this point, still requires some consideration of the actual panels available from the different manufacturers, and either accounting for the variations between the different manufacturers in the design, or picking one particular manufacturer and designing to their panel standards. So it's kind of not quite just a plain vanilla commodity product, but it's really a standardized product that you can work with the manufacturers. And that especially is important if you're getting into the aspect of custom fabrication before being shipped to the job site. How does CLT go together? It's not complicated. It's really screws and bolts and nails and light gauge metal clips. There are special screws that can be long self-tapping screws or different products like that. But the actual assembly details are very familiar to any carpenter. Kind of this picture here shows the red lines represent various types of metal clips and angles that could be screwed or nailed or bolted to the different members. If we look at one particular possible connection in more detail, the kind of picture here could be an example of a wall supporting a floor, supporting a wall above. You stand a wall, you place the floor on top of it. You can use these long self-tapping screws from above to screw that down, place the wall above, and again use self-tapping screws on a metal bracket from the wall to the floor below. This is there are products available that have code reports for this kind of application. These long self-tapping screws, there are several manufacturers of those. And these common, fairly common off-the-shelf metal brackets can be used as well. CLT, is part of a whole wall assembly or a floor assembly. It's not going to be the only aspect of a floor wall, except maybe in like that loft mezzanine, where I think they exposed the CLT from below, where it was the kind of the finished look of the ceiling, but they put a more resilient floor on top of that. These are typically constructed of a softwood, Doug fir or spruce pine fir or southern pine. And they're not going to be a hardwood for a finished floor kind of project. So there's going to be some sort of floor system on top of them. In an exterior wall application, you're typically going to put insulation and weatherproofing on the outside of them to really put the CLT within kind of the thermal and weather envelope of the building. Again, there's lots more examples in that CLT handbook on what different assemblies could look like. So for more information, you can go to masstimber.com and download the CLT handbook. Eric noted this to me when he tried it out. It actually takes you to a different website. It's called rethinkwood.com. If you click on that, but it's really the same place. That's where it's hosted. But you can get that CLT handbook from there. And then on the Woodworks website, we have several case studies of different documents and different information available as well. And if you have any questions, feel free to contact me about any of the topics that we discussed, or send an email to help@woodworks, or contact one of the manufacturers. There's definitely a whole network
on
of
the
people
right-hand
who can
side of the
answer
screen,
questions
for
you
those
may
who haven't been with us
on
before,
the
I've opened up
subject.
a Q&A block. There's a text
I
entry
left plenty of time
point
here
at the
for
very
some
bottom
questions
of
and
that
answers,
column,
so
and
I
you can
hope,
enter your
you've been
questions in there,
listening and have
and
lots
they will
of
show
them
up
for
only
me,
on my
but I can
screen,
help
and
address any
I
questions you
will
have in your mind at this time.
consolidate duplicate questions and look for things that are redundant and read them out one by one for the sake of the recording, and so we'll answer them that way. So if you have any questions, please type them in the box at the bottom of that column and enter them, and we will get started with that. thank you, especially Dr. Breneman. It was a great presentation. I think I learned a lot. Again, as you mentioned, we have the web links down there on the in the web links box for the masstimber.com as well as woodworks.org. And basically, one question was, can you talk a little bit about one of the sustainability attributes is being able to use wood that might not otherwise be usable, such as waste wood or smaller diameter wood or beetle kill wood or something like that?
Yeah, absolutely. I mean, the idea of, one of the manufacturers is using a lot of beetle kill pine, and if you're not familiar with it, there's an Asian beetle that is infesting a lot of the pine forests of, if I can remember the geography right, kind of northern Rockies and up into, the Canadian Rockies, and the beetle comes in and kills a lot of these areas and a lot of the pines in these areas. And as standing lumber, if they can get in there and cut those logs within a couple years, they're still perfectly sound for structural applications like CLT. So that's one of the areas where this wood will, these killed trees will eventually decay and no longer be valuable as lumber, but they can use that in CLT, where it might not be highly graded, as just structural dimensional lumber. But the other aspect is really being able to use the smaller pieces of lumber in faster growing, second growth, third growth forests, and to be able to use like a 2x4 essentially to build up a 12-inch deep by 8-foot wide by 40-foot long structural member that as you see in the screen here, you can kind of see a combination of old construction and probably a 12 by 12 or 14 by 14 column and beam next to some smaller engineered
and also wood, of course, is a renewable
so
resource. We can
really
grow more
use
trees,
these
but
newer growth,
there's only so much metal in the
trees
ground
to
that we
create
can
kind of a
extract
large
as
structural
ore,
component.
and
So obviously
of course the
that's
cost of refining it, even though it is
versus,
recyclable, there's a lot of losses in that.
products
We have another question that came in. Can CLT be exposed to weather?
Um, I'd say that the qualified answer is no, meaning the CLT covered by the PRG 320 standard is not, exposed to weather, is not within the scope of that CLT. Just in terms of the finishes and the gluing and the manufacturing standards, that CLT is not intended for being exposed. I mentioned how there's CLT being used for temporary rig mats and temporary roads. So obviously the capabilities are there for having things intended for use for exposure weather.
Okay. And
about
how does the product compare to some others in terms of product cost?
To weather. That doesn't mean there couldn't be something creative down the road where a manufacturer does that, but that's not currently what is covered by the standard and products available. Yeah, it's a good question. What's a good way to say this? If something can be done with light frame construction, 2x4 or 2x6s at 16 or 24 inches on center, built or not site built, panelized, that's going to be a cheaper structural solution than going with a solid CLT panel. On the other extreme, comparing it to a cast-in-place concrete or steel structure is going to look more favorably. There's lots of, any of these cost questions, there's lots of variability. It's like, how large is the job, how much manufacturing is required. but it falls in that range of it's going to be more expensive than just kind of a typical light frame application, but it's going to be less expensive typically than a heavy steel or concrete application. And then you get into things like, well, do I need it if I need a, I've seen somebody design like a FEMA post-disaster housing shelter where they could have these, panelized and sitting in a container that could be shipped, anywhere in the world within a week and assembled on site with,
And
screwdrivers.
along those lines, in the
And that's not
in that
something
apartment
that's an
building where
advantage that
they
isn't really
use CLT
cost.
panels, but then
You
they
say, well, it's going to
covered
be
them
cheaper
all
or not.
up
That's kind of one of those advantages. It's like
with
it's a
drywall
capability
and
that you can
paint
do
and all
with
that.
this that'd be hard to
Is
do
there
with
a
some other
code
products.
requirement to put a
And so it's
layer
not
of
always
drywall
about
over this
cost,
stuff,
it's
or can you
about
just
what fits the application.
maybe save some more finish costs by using the CLT as the final finish?
Yeah, it's really, it depends on the case. I know in that project in London where you saw the interior shots and you saw it closed up, the developer of this wasn't sure what the reception would be by the community of this tall wood building. So they didn't really want to expose it. They wanted to cover up so it looked like every other kind of apartment flat in that neighborhood. Um, you know, and they used the CLT kind of for the environmental benefit, the low carbon benefit. Um, but then it came around that actually people learned about it and liked it, and they're doing more of them in that neighborhood, and they maybe in retrospect would have liked to have exposed some. The project in Australia, that was the 10-story, they had a combination of portions of the CLT that were covered and portions that were exposed. And I'm sure that was done with consultation of kind of their fire protection engineering and providing, enough coverage of certain portions to meet their fire performance objectives. And that same kind of approach would apply in the U.S. as well. That example of the little mezzanine loft, I think the original plans as permitted by the city required them to cover up the ceiling, but after they had installed it and they got the fire marshal to come out and inspect it and look at it and understand what the product was, he was comfortable with
Some other
that,
wood products like
ceiling
plywood and
not being
things you can
covered
get
up.
with fire-resistant
So
chemical
it's not a
additives,
blanket
or
yes or no, it has to be covered up. It's really
exterior
dependent
grade kind of,
on
or pest-resistant
where you are
additives.
in the code
Are those things working
and
their
where
way
you
into the
are in
CLT
terms of
manufacturing
what your requirements are for
availability,
fire and
or?
life safety protection. Uh, Yeah, yes. I mean, they're working their way in terms of, manufacturers are looking at that, looking at what would be, how does having, fire retardant treated wood, you know, going into the CLT assembly, definitely are being looked at. I don't know of anything that has those available right now. An interesting point related to that is, for example, in type 4 construction, which is our heavy timber construction in the IBC. The IBC 2012 and earlier versions, you had to have the exterior walls had to be, non-combustible construction, or there was an exception allowing fire retardant treated wood in those exterior walls. That 2015 edition of CLT actually says for non-combustible construction or fire retardant treated wood construction, or CLT with a non-combustible or fire retardant treated covering. Meaning you could put a CLT wall as the exterior wall and then just cover it with a non-combustible finish.
Okay, and
you
so
don't have to fire
when
retardant
these
treat
panels are being
the
manufactured,
CLT in
is
the
there
exterior of
a way
type
that they
4
could
building.
allow some
Which is
voids
a
built
question being
into
asked,
the
but it
panel
addresses
for
like you don't
routing
need
of
to fire
electrical
retardant treat that
conduits,
CLT
wires, and things?
in the IBC 2015. You just need to cover it with a non-combustible material. Yeah, I mean, yes, I know several of the European manufacturers do that already, and I know you could consult with the U.S. manufacturers and North American manufacturers, and they may be able to accommodate that. Definitely, I've seen them talk about having kind of a vertical chase for kind of hold down anchors or something like that. Actual chases or routed pathways for electrical or plumbing, definitely has been done on CLT projects before.
Okay.
It kind of is a
Um,
question of, do you want to
okay,
pay
we'll
for
give
the
you a minute
extra
for any other
effort by the
questions to come in.
manufacturer to do
Um,
that and have that all
Otherwise, it seems
coordinated versus
like
some other on-site
this
approach?
seems
It's
to
kind
be
of an
something
interesting
that we
trade-off
might be
question,
very well
but
seeing in our
the
future.
manufacturing capabilities are
It kind of
definitely
reminds me
there.
of plywood on steroids. Um, so, and also, thinking back, we had, it used to be common to see, 3-inch thick tongue and groove wood decking just in planks used in a lot of industrial areas that kind of gave way to metal pans. But maybe that kind of thing will be coming back with CLT. Um, that's interesting. Have you heard much of United States manufacturing coming online, or about what kind of time frame that might be?
Yes, I mean there's a company in Oregon that just recently announced their manufacturing, and they're literally like working on their presses today, I'm sure, where they're coming online here this year. I don't know what their time frame is. Um, and they're, what is it? DR Johnson is their company name. They're from Riddle, Oregon. There's another company, Idaho Forest Group, who's partnered with KLH, who's a CLT manufacturer in Europe, and they have a venture, KLH USA, which is intending to manufacture, in the U.S. based upon the European experience in this partnership. And I've heard of others kind of in the works, but those are the two that are publicly acknowledged U.S. manufacturing facilities, either in construction or on the drawing boards. The PRG 320 standard kind of has options for using Doug fir, spruce pine fir, and southern pine. So there's obviously some interest in the southeast of using southern pine as the
Okay.
core material going into
Well, as
CLT
a
as well.
reminder to
So that'd
people,
be
we have
another
oops,
region
there
that
we
could
have the
get
file share
involved with
box
local
down at the bottom here
manufacturing,
with the
but there's
copy of
nothing
of
public
the
that I know
presentation
of
available for download
manufacturing
if
coming
anybody
online
wants
there.
to take another
Not to say
look
there's not anybody
and
doing
get
it, but
these
there's not any public acknowledgement of it yet.
email addresses and things. And also in the web links, we have a link to the woodworks.org as well as the masstimber.com, which forwards, of course, to the new name, I suppose, or whatever they want to call it, the Rethink Wood. And that's a great place for the manuals and design guides and things like that they have on there. Spent a while downloading a lot of those myself, and I think this is going to be something that'll help us out and be a useful resource in the years to come as these things come online. Thank you again, Dr. Breneman, for your time, and I'm going to sign off now, but I'll leave this web portal up for a few minutes for people that want to take advantage of that download or copy these links. Again, also in the links, as with every webinar, we have our prior webinar videos as well as a link to our new sustainability and energy site. Of course, that bottom one, the new sustainability and energy site, is on the Mercy service MRSI that has to have a login from a military approved address. Otherwise, most things are available. I've got one more last question that just came in since we have a little bit of time here. Is there any research on the use of adhesives only for the assembly of CLT in lieu of screws and hardware?
Um, oh, for adhesives on site, on site adhesives. That's an interesting question. I have not heard of any research of on-site adhesive use as a major way of assembly, and I think one of the reasons why adhesives have a hard time for on-site construction is really just kind of how do you inspect them? How do you have quality assurance on them? I mean, adhesives are used, in all sorts of products like glulam and CLT, but under kind of constant supervision at a manufacturing facility. On site, they become a little more challenging to get the ascertain and ensure the quality of one of them, and how much adhesive is in place, and how did it cure. And once it's members are together, it's not something you can easily inspect. Like you can count the number of screws on the side of a panel. So I've not heard of any on-site adhesives work, although I have heard of adhesives research at I think it's Clemson, looking at kind of composite systems where you may have like a CLT with kind of a flange configuration where it's not just a solid panel but more of a T-flange or T-beam system using different adhesive technologies. But again, I think that's more manufacturing use as opposed to on-site. But a good question.
Great, thank you very much. I'll sign off as well.
And thank you,
and
Eric,
again,
for allowing me to come here and talk about this today.
Can
and if
keep an eye
anybody
on
has
that
additional
Sustainability and Energy
questions,
site. They'll be posted on there probably
the
within
PDF
about a week.
from the file share and
thank you all for
find
joining
my
us
contact
today.
information there, and drop me an email or give me a call. Thank you.